Hey, what's going on, guys? Let's try these problems right here. The first question is asking an astronaut in an inertial reference frame measures the time interval delta t 0.82 seconds between her heartbeats. What will observers in all other inertial reference frames measure for the time interval between her heartbeats? And here the first situation we have is the same location as her, and the astronaut measures this heartbeat, right? That's delta t. But when we consider other inertial reference frame, what's going to happen is this delta t is going to be affected by gamma. So we are going to have the time that is length longer by gamma. So we are going to have delta t. Let's say the new delta t is going to be delta t prime. That's going to be gamma times delta t, right? And if you look at the equation for gamma, you will see gamma is equal to 1 over square root of 1 minus v square over c square. And this is definitely greater than 1, right? Because we don't have anything higher than speed of light, and we are going to have positive number. And if you square root this one, that's going to be definitely less than 1. So we are going to have a greater number than 1. And that's going to make this one bigger, right? So the correct answer would be more than delta t. So answer A is the correct one. And let's look at the second part. Second part is saying how fast would a 4.6 meter long dinosaur have to be traveling to appear to be only 2.24 meter in length? Report your answer in meter per second and these things. Okay. Now let's see. So first of all, at rest the length is this one, right? So let's say L naught. L naught is at rest. The length is 4.6 meter. And here we want this one to appear this much length. So we are expecting related to speed, we have to have this length 2.24 meter. Now here, in order to calculate the velocity to make this one look like this long, we have to use Lorentz contraction equation, length contraction equation. That's going to be L is equal to L naught square root of 1 minus v square over c square. Since we are trying to find v, we have to rearrange this equation. So this is going to be L over L naught is going to be this one, and if we square this one, we can get rid of the square root. So we are going to have 1 minus v square over c square. Let's bring this v square over c square to this side and this one to other side. So if we do that, that's going to become v square over c square is equal to 1 minus L square over L naught square. And since we are trying to find v alone, we can move this c to the other side too. So v is going to be, since we have v square, to find v we have to square root this one, 1 minus L square over L naught square, and also we are moving the c square to the other side, and if we square root c square, that's going to be c. And now we can go ahead and plug the values. So first of all, let's plug it right here. We have this equation, this is the main equation. Now let's go ahead and plug it. V is equal to square root of 1 minus L square is the length we have to have when it's moved with a certain velocity. So that one we want it to be 2.44 square over the length at rest is 4.6 meter. So 4.6 square, and then speed of light is c, that is 3 times 10 to the power of 8, right? And if you calculate this one, if you solve for this one, you should get around 2.62 times 10 to the power of 8 meter per second, right? And that's going to be the final answer. I hope this helps. Thanks for watching.